Okay, thank you again for coming. I'm Matt Bishop, product architect here at Elastic Path, and I wanted to talk to you today about our experience with microservices as an architecture and how it connects and benefits from our API style, which is known as Hypermedia APIs. So Peter just showed you this slide, and we love this slide because it puts the important part to us anyway, our commerce, into proximity with the other important part, which is our customers, or our customers, if you will. We think top down at this company. We really think about the experience that those touch points have with commerce makes a huge difference in actually making sales and making the business that's running this platform successful and engaging their customers and giving them products and services that they actually want. So the top down is really important to us. It's important to our customers. They love this story because they have the same kind of vision. They want to connect their products and services. They want to integrate into the fabric of their customers' lives as much as they can. The thing about these guys, though, is they don't actually build a lot of their own software. They turn around and hire these guys to come build that software. These are our partners. And what happens more and more and more is when we sit down to actually figure out how to do this, they pull up a slide that looks like this. And they say to us, your space is right down here in the middle, and there's going to be something between you and all those touch points you love so dearly. So figure out how you're going to do your thing here, and we're going to handle that top part on our own way. So this is a microservice slide if you can't read it in the back. Not everybody does microservices, but more and more of our customers and prospects are looking at going this architecture. And so we really need to think through what are microservices, how does it impact us, what does this have to say about our goal of actually connecting to our customers through the omni-channel experience. So a little breakdown of what microservices are. Simply put, it's breaking a big application into a bunch of small applications. I found this great picture. Basically, the way they describe it is your big application on the left has been broken into teams. The problem with most team-based monolithic applications is you're still producing a single product, the pie. So you have to figure out how to put the pie together at the end of the release to actually ship it. Microservices is basically saying, forget about the shared pie. Everybody makes their own cupcakes. And you don't have to worry about the other people. You just produce what you need to do and move on. Another way to describe this is imagine Office was a single application and they broke it up into individual pieces of software. And I actually like this example because one of the key aspects of a microservice is it had its own data store. And all of these have their own data stores. Those are the file types. You don't open PowerPoint files in Excel. You don't open, you don't use Access to check your email. So they have isolation from each other, but they also have a commonality of purpose to produce an Office experience. A big question I ask our partners when they talk about microservices is why? Why are you guys doing this? And the answers kind of boil down to three things, centered on the main goal of they really want to have agility. They want to have speed. They want to produce new features as fast as possible without having to coordinate with other teams, without having to have like a master plan that we're all going to release the software. I want to be able to release stuff and scale it independent of everybody else. And that is a really good goal. And I can see why people want to do this. It's worth a lot of the pain, because there is pain. Microservices are not an easy solution to implement. These are a few of the problems that they come up with or discover as they go into an architecture like this. It's really hard to figure out when it goes wrong. It's hard to figure out who owns it over time. You get 20 microservices, that's great. It's pretty easy to understand. You get over 100, over 200. Some people have over 1,000 microservices in their ecosystem, written by people who don't work there anymore and sourced in locations they can't find. So the ecosystem of a microservice architecture is not a release product. It's an organism that grows and has to be managed and cared for. So over time, it actually has some challenges. Three of the hard parts that we think are interesting are the discoverability of those microservices. How do I find them? Usability and orchestration. So how do you find one of these microservices? Again, if there's 20, not a big deal. If there's 200, it gets a little harder because you need some way of cataloging and discovering where they are and what they can do. And once you've found it, then you have to learn how to actually use it. So Swagger is a company that produces tooling to produce documentation and testing kits for APIs. And they've been very successful, large because it gives people who produce a microservice a way to actually document how to use the service they're in a nice format. And it's been pretty successful. It's actually helping you figure out what a service does and how you might want to interact with it. And then finally, how do I bring these microservices together? How do I orchestrate them into a product that I need to sell or need to service? And this is where it gets a little harder, because the connections between microservices is supposed to be loosely coupled. They're not supposed to have a lot of dependencies on each other, which is great. There is some connections. It's usually things like the product code or the user ID or some kind of ubiquitous language identifier that can cross the services. But it isn't always obvious looking at this. And it's up to the mind of the developer writing the application to connect the dots themselves. They have to think about, okay, this service calls it user ID, that service calls it user. I think it's the same thing. I'm going to try it. A lot of experimentation, trying to make it work together. This is a hard problem, and microservices as a something came up with this pattern called the backends for front-end patterns. And this is the de facto way of tying stuff together. It came out of this guy named Sam Newman, who's quite familiar and drives a lot of the thinking around microservices. And he basically describes this as a microservice that serves a single client. And that single client knows how to talk to all the microservices underneath, so that your client doesn't actually have to know the microservices. It just knows this single point of contact for its own thing. The interesting aspect I find to this pattern is that it's expected that the client developer team owns this microservice. This is the only time those people get into the back end and do anything useful for themselves. So they own this thing. Now I'm going to walk you through his presentation a little bit to explain what it's for. And I'm sorry it's not, you can't really see. Down here are some circles with arrows, and these are microservices. So this is the starting point. Generally speaking, you have touch points above. They all have to share this API in the middle, and that API in the middle talks out to things. In reality, there are different teams for each one of these blocks. And the general purpose API is managed by a single team. And that team is very popular, because if you want a microservice down here to support something up here, you got to negotiate with these guys. And you got to convince them that your feature is more important than their feature and that it should go in first. And so this structure causes a lot of conflict in organizations in getting capabilities out. So Sam suggests, instead of having a single API, you can solve the fighting by splitting it in two and saying, we're going to have two different APIs. These are the backends for front ends. And for mobile clients, we're going to just, all the mobile guys are going to share that one, and all the web people are going to share the web one, and they'll never have to talk to each other. It's going to be great. And they're never going to fight, and they can just move on and get the rapidity, or the speed, the agility they're trying to get with microservices in the first place. It's a recursive process. If you find that you can't share the mobile very well because you're still fighting over features, you can split it again. And you can have an iOS version and an Android version. And again, and again. So that these things split as needed to support the client. So how do you build these things? Because at the end of the day, you have to have some kind of API for your device, your touch point to actually communicate with. JavaScript developers, remember, these are the people responsible for it, or Swift developers, or Android developers. So they have made Node.js really popular. One of the reasons is because this is where Node lives and serves a useful purpose, is that the JavaScript developer can actually write a BFF. Gateways like Apogee provide some tooling. They have transformers that can run JavaScript, and they'll use that layer to actually communicate and create a BFF-style interface. Netflix, which is the source of much of the microservices pioneering work, has an answer themselves. I'm going to walk you through it. It's called the Dynamic Scripting Framework. So Netflix basically found with their API, this is about 5 or 6 years ago, that their traffic looked a lot like this. The stuff on the left here is calls coming from their clients, the Xbox, the mobile phone, whatever. And it goes to a general purpose API, and then all the services are accessed on this side of the wall. As requests come in and responses go back, the client makes additional follow-on requests to get more data based on the content of the first request. Overall, this is slow. So they wanted a way to do this. They wanted the client to make a single request and then have all that stepping and follow-on work happen on the server side of the line so that the amount of time the client actually waits is reduced. And they don't have to pay the penalty of the stepping on the client side. They can do all that cost on the server side. It's a great idea. They built this architecture. And the green things are the BFFs. And there's one up there for Xbox and PS3 and etc. Now, I've used Netflix for several years. Last night when I was thinking about this, I've counted 6 clients I've used it on. My Blu-ray player, my television, my iPhone, my Apple TV. There's a couple more. The web itself. If you use this product, if you use any product like this, you can think there's going to be more than one thing. What struck me was they all basically do the same thing as the other ones. In fact, there's a point of pride at Netflix that the experience is identical as much as possible between your Blu-ray player and your web browser. They really want it to be the same experience across those things. To get there, though, they have to write all these stacks that go all the way through down to the backend service. This is where their microservices live. And this is the problem that they solved with this. Those client developers get to write scripts, basically the same code across all of them. They have, I think, over 1,000 client types that they support now out of the box. I don't know if there's 1,000 of these, but there's certainly more than 4. And again, I think they say the same thing. Now, one thing I've learned is that companies are made up of people who don't always agree with each other. The UI team at Netflix, which is not the same group as the API team, have put out a product called Falkor. It's an open source project, and it's basically their way of describing what they would like to be doing. Because the reality is they don't like writing backends for front ends. They really don't want to do this. They don't think it's their problem, right? They're being forced into a solution that fixes a server-side problem and a network problem, but it doesn't give them a way to actually solve their real goal, which is a user experience. So Falkor, this is coming from their site, they want to interact like this. They want their device to talk to a single endpoint and get a model. And that model magically gets backed up by all the services that know how to back it up. I'm going to zoom in a little bit to make this point really clear. The model they're describing is a directed graph. It's things that have relationships to each other. And they want their code on the client to look something like this, where you say, okay, I want to go to that model, and I want to get the user's first name, the user's last name, and their address. And I want you to just send that back to me. I want to use this simple query-like structure to work in the graph and pull back the data. Because this data is interesting for all the touch points. And there's nothing client-specific about any of this. What's really interesting is the client itself is deciding what to ask for. So I think Falkor's interaction model is pretty much the same thing as a Hypermedia API. And what I think it means to me is clients are fine with that. They get graphs. They understand how that works. And they actually want to interact with it that way. So I'm going to take you on a little tour of Hypermedia. There are basically 2 concepts you have to understand. There are resources, which are the things of the world, and there are relationships, which are named relations between them. They go in 2 directions. They can go in 2 directions to say they have a name. It's fairly obvious, but I'm calling it out because other than this, there really isn't that much to know about a Hypermedia API. We have a few types of resources. There are some resources that produce data, like address in my example here. Other resources produce lists of them. Addresses points to address resources. And there are control resources which let you create new resources, like an address form resource. Using a Hypermedia API is kind of like browsing. You start at the root, the home page, if you will. You click through links. You follow links with get. You see something you don't like, you can delete it. Send a delete command in HTTP. If you want to change it, you can modify the data and put it back. And that sets the new values to match what you want it to be. If you find a control that allows post, you can post a form and create a new thing. And then you can go back to step 2 and start again. And this is pretty much it. Using a Hypermedia API is exactly like browsing the web with a browser. And that's on purpose. So I'm going to give you a little demonstration using our API. There it is. Okay, so we have I've already set this up. If I go to slash and call get, I'm going to get back a bunch of links. And these links have names. In this case, default card, navigations, profile, create an account, and searching. And our tool, which is a fairly simple tool, a lot of Hypermedia APIs have tools that look very similar to this. You click on a link, and you can go in, and in here, you'll find a form. And this form, one of those form resources I talked to you about, lets you put things in. So I'm going to put boots, and there's a link on here to say, here's where you send the form. I'm going to post it. I'm going to get back a list of links to things that are boots. If I go in, I'm going to find out the availability. I'm going to have a control to add to the cart, and I can have other things, the definition, the deeper definition of it, etc. So using the API, we have a tool that browses the API, and nothing I'm doing in this tool is all that different than what you would do with a code client. So we've been doing this for about 5 years now, and we've come up with some advantages or discovered some advantages that we really wanted to share with you today. The first one is it's discoverable. It's really easy for a client developer to do just what I did, start at root, walk their way through the API, and learn what there is to do, what's possible, and where to find the data from. This discoverability is really important because the documentation is hard to write. In fact, we don't even have Swagger docs because we don't need them. You don't actually construct URIs to interact with an API. We don't have a big catalog of every resource there is in the world. You walk through the API, you discover it in the context that it makes some sense. Another important advantage is that the workflow itself is self-discoverable. If you want to know how to add something to a cart, you start at the something, and then there will be a link there to the add to cart form. The fact that a link will appear means that it is relevant and available. And this is really important for workflow because in shopping and in almost anything, sometimes you can do something and sometimes you can't. If the client has to figure that out, they have business logic in the client. And this is a fail because with one touch point, yeah, it's in the template page, it's in the JavaScript, whatever, will live. 2, we got to copy it. 3, you're copying. Remember Peter's curve, all those things, they all now have to copy this little rule about when can I put something in the cart. And now you apply that to all the rest of the business rules. And you find out pretty quickly that this is a fail, this is a really bad idea because you cannot replicate all the rules across all the touch points successfully and get that commerce experience, that rich experience we're trying to achieve. So with the way clients work with a Hypermedia API is they react to it, right? They don't know if they should add to the cart. They know that there's a cart. They know that they can add things to it, but they don't have to decide when it's possible. And that makes a huge difference because the business rules live in the server and they live nowhere else. Another one is versionless stability. Most APIs have a version number in them somewhere. There's like a /v1 or someplace in the header there might be a version. And it's really important because as it was with SOAP, whenever you make a change to a non-Hypermedia API, you're probably going to have to make a new version of it so that the clients don't break. With Hypermedia, we've discovered we don't actually have to version the API. For the most part, the relationships don't change. And by using normalization rules, which is coming out of the database world, we can create resources that are stable. Their data fields don't have to come and go. And they can become stable and last for a really long time. So one claim I made is that relationships never change. And the reason is, and forgive my philosophy here, is that because we're animals. And animals get relationships, down to the ants who know their queen, kittens know their mother. We can look at the world we're trying to interact with, and we can identify, first of all, the things separate from each other and the relationships there between. And we can communicate that in a way that everyone else understands too. In creating this API, we have about 300 endpoints now. We've never, at least I don't think we've ever had to explain what a relationship means. It's self-evident by reading the word. And when we create the API, we spend more time thinking about if we've broken it down small enough than we do trying to name the relationships between stuff. The relationships themselves are pretty obvious. Okay, nothing's perfect. Hypermedia has one massive problem, and that is the chattiness. Clients don't like making lots of calls. This was Netflix's original problem. They don't really want all this nesting and digging going on because it's slow, and they're right. They really wanted to do this instead. Excuse me. We had to solve this problem ourselves, and so we decided to create a technology called Zoom. Now, Zoom lets us do what, that's why this is here, lets us kind of do what this is doing. This is from last year, and ours started about 4 years ago. And basically it says, I want to go into something, and while you're there, get these other things that are associated with it. And then on the server, it's going to make those additional calls, collect that data together into one response, and send it back to the client. So we actually do this with our Hypermedia API, and we mix what Falkor does with client-directed inclusion and produce an output that is rich and tuned exactly to what the client has asked for. So I'll show you a little example. So here I'm looking at a particular item, and we have this tool up here. And so I'm going to say I want the availability, and I want the price. We've got some autocomplete to make it happen, and I want the definition. In this one request, it's going to go and it's going to pull all these things in, and it's going to embed them into the content here. You can strip some of the stuff out, but you get the idea. The client can decide if they want to see the definition. If the client says, you know what, I don't really want to see all the definition, I'm a small mobile device, I really just want these two things, they change their query and they get it back. With something like a BFF, you would have to write a new BFF or change the BFF to make this change. And that's the problem, is that you don't have the agility you need with BFFs to actually let the client decide what to come back with. So I really believe that Hypermedia makes microservices a truly interesting architecture because it solves the problem of accessing those resources in a model that the client understands and that favors the client's use cases. It actually brings the agility forward. It solves these three hard parts quite well. And so we're very excited to share that with you. Thanks for coming. I can take some questions or comments if you would like.